I want to explain how we can use Hess law. They said that how you can use Hess law to calculate the enthalpy change of a chemical reaction. You know, chemical reaction is when we have reactants and product together. So we are told to determine the delta H. Delta H is the enthalpy change. This is delta H of this reaction from this following data. The data is when we combust carbon and oxygen, it gives us carbon dioxide. And it was stated that it has minus 3.93.7 kilojoule. One thing I want you to understand here is that for every enthalpy change, delta H, the unit is in kilojoule. That's the first thing. The second thing is that we have two types of reaction. It can be endothermic or exothermic reaction. When it is exothermic, we have this minus. And when it is endothermic, it's the positive. All these ones are exothermic reaction. So now, the second reaction, they combust hydrogen and oxygen to have H2O water, is exothermic as well. So they combust methane and oxygen to have carbon dioxide and two molecules of H2O. Now, doing this solution, one thing you must first do is that you know that we have three types of reaction there, like CO, the three ones, they give us this enthalpy change, all these enthalpy changes. First, write them out by saying C plus O2 gives CO2. This one we have H2 plus O2 to give us H2O. And the last one we have CO2 plus the last one we have not CO2. The last one we have CH4 plus O2 molecules of oxygen gives us CO2 plus 2H2O. You know, you are going to find this. This is what you want to find. You want to find C plus 2H2 will give you CH4. This is what you want to find. Here, look at here very well. You will notice that here, it means that from these three equations, when you combine these three equations together, you must find your, you know this is the reactant side, this is the product side. Your reactant must be C plus 2H2. That's the first thing. And your product must be CH4. And if you look at this very well, from these three equations, you already have your C here. You have your C, you have it here. You have your H2 here. But your CH4, which is supposed to be here, is not here. So, one thing you should understand is that if you want to change this one, like you want to change the reactant to the product, like you want to reverse it. The sign here that is ours, you know, the enthalpy change was negative. If the enthalpy change was negative, it will turn to positive like that. If it is positive before, it will turn to what? Negative. That's what I want you to know. But let me first do these two first. To have this reactant side, I must first do them. One thing you should know is that I have two molecules of hydrogen here, 2H2. I have 2H2. You know I have C plus 2H2 gives me CH4. Let me do this first. I have carbon here. I don't have any business with this carbon since it's already here. This 2H2, I will multiply across this by 2. I will say multiply this by 2. So this one will now be 2H2 plus 2O2 will give, you know, when I multiply this 2H2O, that's what this one will give me. 2H2O, that's what this one is going to give. And you must know that it means since I have already multiplied this one by 2, it means that this one has turned to this. And this one remains this A. And I hope I'm making sense. Another thing you should focus on here is that, you know, from this question, it will be like, how do I now combine them together? Okay, now, since I've already multiplied this one by 2, one thing you should notice here is that, let me now write these two equations, this one, and this one that I've multiplied by 2. The new equation now is C plus O2 gives us CO2. And you know I have 2H2 now, because I've already multiplied by 2 plus 2O2 will gives 2H2O. Now I want to cancel this one and this one. I want to cancel this and this. Yes, I want to cancel this and this. Sorry, I made a mistake. And the mistake I made was that this one, which is supposed to be, this one originally it was half 1/2. Oh, my bad. This is 1/2. So this one will be 1/2 multiplied by 2. It will not be 1 like that. So this one will not be there anymore. This one will not be there anymore. So I will have O2 like that. It will be O2 because it's going to be halved. So now, since this one is O2, just this one O2, it means that I can't. Let me pause. So now, if I want to continue this, I have these two equations now. You know that, this one was half. I made a mistake. It means that when I want to combine this equation, when I want to combine these, combine. This and this is going to cancel. It will now remains this plus 2H2 will give CO2 plus 2H2O. I have this thing. Now don't forget that these two equations are the two equations, this 1 and 2 are the two equations here. This one, the first one, this first one, and this second one here. I've already added them. The enthalpy change of this, I'm going to add them. It means I will now have the two enthalpy change, which is going to be 393.7 plus 285.7. Know that. So it means that the enthalpy change for this will now be, enthalpy change for these two will now be equal to 393.7 plus 285.7. If you add them together, 393.7 plus 0.7 plus 285.7. Okay, you are going to have something like 679.4, like something like that. So now the third equation, the third reaction, we have this, which is minus 18, and we have this equation. I said that since we want to use to cancel this, we are going to change it. When I change this, when I reverse this one, I said if I reverse it, the sign that is here, this sign that is here will change. If it is negative, it's going to change to positive. If it is positive, it's going to change to negative. So instead of writing CH4 plus 2H juice, I will now bring this one as the reactant and this one as the product. This one is the reactant. This one is the reactant. I will now reverse it. So I will now have CO2 plus 2H2O will give CH4 plus what? 2O2. So this delta H will now be equal to plus 890.3 kilojoule. So now this one will now be, combine these two equations. If I have to combine them, I have this. So this one will be combined. Now this one will now be C plus, so this one will be C plus 2H2 will give CO2 plus 2H2O, and this one will be CO2 plus 2H2O will give CH4 plus 2O2. Here, this one and this one are common, you cancel them. This one and this one common, you cancel them. So what else remains? It remains 2H2O. This CH2O. Oh, I have 2HCO here. Another mistake I did. God. The mistake I did here. Let me explain. Yes, I did the mistake. It was because I paused it before. I paused the video because some people are making noise. Here, this one and this one, when I combine them together, I will not cancel them. It's a mistake on my part. This one and this one, I will add them together. You know, this one is 102, 102. So this one will now be 2 in form of 2. Like 1 plus 1, O2 plus O2 will now be 2O2. So this one will now be plus, this one will now be plus 2O2. 2 oxygen will now give this. So now, if I want to now combine it to the third one here, this one should have 2 CO2 like that combined. So this one will now be plus, this one will now be written in form of it will now be written in form of C, you know, plus 2H2 plus 2O2. So when this H2 C, okay, when these are hydrogen cancel this, when I add them together, the one at the reactant is going to cancel the one at the product, and the one at the product is going to cancel the one at the reactant. This one and this one cancel, this one and this one cancel, this one will now cancel this. So it's now left with C plus 2H2. We give this one alone, CH4. And one thing I want you to understand here is this. One thing I want you to understand here is that, you know, this, the enthalpy change. So the enthalpy change will now be equal to 890.3 kilojoule. You know, this one has turned to positive, minus, what do we have as this one? Minus 67 something. 679 or what? 679.4 kilojoule. So when we have this, so this one is plus or minus. So I find the answer, sha. When you get the answer, that so the enthalpy change, your delta H is going to be whatever things you find. And I hope you really understand this very well. So I wish you the best. Probably it should be minus 74.8 kilojoule or whatever, sha. I will do another question now.